Hello student, in this video lecture I am going to solve some examples on binomial distribution. Now the first example is, let x follows binomial distribution with parameters n and p. Then the comment on the expected value of x equal to 7 and variance of x equal to 12. Then the second bit is expected value of x equal to 4 and variance of x equal to 3. And what are the values of n, p, q? And the third bit is, if n equal to 10 and expected value of x equal to 5, find p, gamma 1, gamma 2, and comment on the nature of the distribution. Okay, now first we solve the first bit, that is solution of this problem is bit number 1. In the problem given that expected value of x equal to 7 and variance of x is equal to 12. Then we know that the theoretical mean of binomial distribution with parameters n and p is expected value of x equal to np and theoretical variance of binomial distribution with parameters n and p is npq. Okay, then the expected value of x equal to 7, therefore we have np is equal to 7 and variance of x is equal to 12, therefore the variance of random variable x is equal to npq, therefore npq is equal to 12. Okay, therefore np is equal to 7 and npq is the variance of random variable x, which is equal to 12. Here np is equal to 7. Now put the value of np in the variance of random variable x, then we have 7 into q is equal to 12. This implies that q is equal to 12 upon 7, which is greater than 1. Therefore the given statement is false, because q is the probability and q lies between 0 and 1, and here the value of q is greater than 1, therefore the given statement is false. Okay, then the second bit is in second bit given that n is equal to 10 and expected value of x is equal to 5. Then find the values of p, gamma 1, gamma 2 and comment on the nature of the distribution. Okay. Then we know that expected value of x is equal to np. This is the theoretical mean of the binomial distribution. Therefore np is equal to 5. This implies that p is equal to 5 upon n. Again this implies that p is equal to 5 upon 10, that is value of P is equal to 0.5. Then we know that P plus Q is equal to 1. Total probability is equal to 1. Therefore, P is equal to 1 minus Q, which is equal to 1. Sorry, here is Q is equal to 1 minus P, and which is equal to 1 minus 0.5 equal to 0.5. Then we know that if P is equal to Q is equal to 1/2, then the value of gamma 1 is equal to 0. If value of gamma 1 is equal to 0, then the distribution is symmetric. Okay. Then gamma 2 is equal to 1 minus 6 into PQ upon NPQ. Here substitute the values of NPQ, then we have a value of gamma 2 is equal to minus 0.2, which is less than 0. Therefore, the nature of the distribution is symmetric and plateautic. If gamma 2 is less than 0, in that case the type of distribution is plateautic. Therefore, the type of nature of the probability distribution is symmetric and plateautic. Then we see the bit number. Next bit, expected value of x is equal to 4 and variance of random variable x equal to 3. Then what are the values of NPQ? Okay, we know that expected value of x equal to NP, therefore NP is equal to 4. Expectation of x equal to 4, and variance of random variable x is equal to NPQ. Therefore, NPQ is equal to 3. The variance of binomial distribution is NPQ. Now, NP is equal to 4. Put the value of NP in this equation. Then we have, therefore, 4 into Q is equal to 3. This implies that Q is equal to 3/4. Now find the value of P. We have a Q is equal to 3/4. Then we know that P plus Q is equal to 1. That is, total probability is equal to 1. This implies that P is equal to 1 minus Q, again, which is equal to 1 minus 3/4, which is equal to 1/4. Okay, Q is equal to 3/4 and P is equal to 1/4. Then how to find the value of N? We know that NP is equal to 4. This implies that N is equal to 4 upon P, which is equal to 4 divided by 1/4, which is equal to 16. The value of parameter N is equal to 16. Then we have a P is equal to 1/4, Q is equal to 3/4 and N is equal to 16. Okay, Now we see the next example on binomial distribution. If x follows binomial distribution with parameters n1 equal to 5 and p is equal to 1/2, y follows binomial distribution with parameters n2 equal to 8, p is equal to 1/2, and x, y are independent, x and y are independent, then find probability of x plus y is equal to 5. Probability of x plus y is equal to 5. Okay, to solve this example we use additive property of binomial distribution. Now by using additive property, we have x plus y. This follows binomial distribution with parameters n1 plus n2 and p. That is x plus y. This follows binomial distribution with parameters 5 plus 8 and 1/2. Again this is equal to this x plus y follows binomial distribution with parameters 13 1/2. Suppose z is equal to x plus y. Now the probability mass function of the random variable z is probability of z equal to small z, which is equal to 13c z into p raised to z into q raised to 13 minus z. Here z takes values 0, 1, 2 up to 13, 0 otherwise. Therefore probability of z is equal to small z, which is equal to 13c z into 1/2 raised to z into q is equal to 1/2 raised to 13 minus z. Here z takes values 0, 1, 2 up to 13, 0 otherwise. Then required probability is probability of x plus y is equal to 5. That is probability of Z is equal to 5. Now substitute value of Z in the above probability mass function, then we will get the required probability. Now 13C 5 into 1/2 raised to 5 into 1/2 raised to 13 minus 5, which is equal to 13 factorial upon 5 factorial into bracket 13 minus 5 factorial into 1/2 raised to 5 into 1/2 raised to 13 minus 5, which is equal to 8. Okay, again which is equal to 13 factorial upon 5 factorial into 8 factorial into 1/2 raised to 13. Then solve this, we will get the required probability, that is probability of Z equal to 5. Okay, this is the required probability of, that is Z equal to 5 and Z is equal to x plus y. Okay, that is the probability of x plus y is equal to 5, which is equal to 13 factorial upon 5 factorial into 8 factorial into 1/2 raised to 13. The third example is a radar system has a probability of 0.1 of detecting a certain target in a single scan. Find the probability that target will be detected at least twice in 4 scans and at most once in a single scan. Okay, then in the given problem we have to calculate the probability of detecting a certain target. For that, first we have to define random variable x. The random variable x is equal to, let x be the number of times target will be detected in the 4 scans. This is the random variable x. Then in the problem it is given that the probability of detecting a certain target which is equal to 0.1, that is p is equal to probability of detecting a certain target and p is equal to 0.1. If p is equal to 0.1, then the value of q is equal to, we know that q is equal to 1 minus p, which is equal to 1 minus 0.1, which is equal to 0.9. Okay, then n is equal to number of scans, that is value of n is equal to 4. Hence the random variable x, this follows binomial distribution with parameters n equal to 4 and p is equal to 0.1. Now the probability mass function of random variable x is probability of x equal to x, which is equal to nc x into p raised to x into q raised to n minus x. X takes values 0, 1, 2 up to n, 0 otherwise. Then the required probabilities. In the first bit we have to find out the probability of target will be detected at least twice, that is probability of x is greater than or equal to 2. Now this probability of x is greater than or equal to 2, this can be written as 1 minus probability of x less than 2, which is equal to 1 minus probability of x equal to 0 minus probability of x equal to 1. Now substitute the x equal to 0 and x equal to 1 in the above probability mass function, then we have 1 minus 4c0 into 0.1 raised to 0 into 0.9 raised to 4 minus 4c1 into 0.1 raised to 1 into 0.9 raised to 3. After solving this, required probability is 0.0523. This is the required probability, that is probability of x is greater than or equal to 2, that is probability of detecting a target at least twice in a 4 scans. Then the second bit is the probability of detecting a target at most once in a 4 scans, that is probability of x is less than or equal to 1. This is equal to probability of x equal to 0 plus probability of x equal to 1. Now substitute the values of random variables x equal to 0 and x equal to 1 in the above probability mass function. Then we have 4c0 into 0.1 raised to 0 into 0.9 raised to 4 plus 4c1 into 0.1 raised to 1 into 0.9 raised to 3. Then the required probability is equal to 0.9477, which is the probability of detecting a certain target at most once in a 4 scans. Thank you.